Bueno, buenos días, good morning, welcome to this talk from Dr. Marc Stutter from the James Hutton Institute from Scotland. We have the pleasure of having him today with his talk from buffer research to practice, rethinking repair and management through science, policy and actions. Dr. Stutter is a PhD in soil science and a researcher from this institute in Scotland. Okay, welcome. Thank you.
Okay, thanks for having me and making me feel welcome in Uruguay, and we can learn together about buffer zones and protection of water courses from diffuse pollution and other aspects. So I'm just going to start the talk, and thank you for listening in English. Okay, so this is my title. I'm from the James Hutton Institute in Scotland, so an institute with some parallels to INEA. So this is what we're going to look at today. So we're going to explore the context and need for edge-of-field diffuse pollution mitigation and riparian zone restoration, and I'm going to speak from a UK and European context, and hopefully bring some messages to your country. So this talk's going to look particularly at some of the policy aspects and support for some of the science to be put into practice, with hopefully some recommendations. So some key questions. So why are we improving the water environment? So to do this, we need to understand what are the current and future issues, what we need to do, where is it needed and at what scale. Are there actions compatible with rules, structures and wider aims of policy and society? How to influence and be persuasive and get land managers to carry out some of the actions, and indeed how will it be paid for, an important question. So the talk is laid out a little bit in the structure of those sections. So to do this, we need a combination. We need, especially at the top end of that list, we need some good science. In the middle and across that list, we need some policy to support us and be clear about what is needed and how to do it. We need delivery on the ground, and we need finance. So a very small bit of background on my institute. So I come from the James Hutton Institute. My base is in Aberdeen on the east coast of Scotland. So you can see the dot in the map. I've lost the little clicker. So on the east coast of Scotland, thank you. So the institute has two sites. Our one in Aberdeen is more an institute with offices and laboratories, and the one on the Dundee site, which is in the lower right photo, is more a site with agricultural field trials and glass houses, and the Science Institute on a farm. So we're an interdisciplinary institute. So we have three main science challenges. One is very much about production and support of agriculture, but sustainably. So that's the top one. The one that we work on a lot in our institute is about protection of ecosystems and developing multiple benefits approaches to managing ecosystems. And then delivering technical and social innovations, supporting communities. So the structure of the institute is through five science groups, and I'm working in the environmental and biochemical sciences. So when we do research, it's very much about raising impact through the research. Part of that, we have some mechanisms that we deliver science through, some structures. Some of those are catchment partnerships and working with external bodies like the D Catchment Partnership, and Riverwoods, which I'll tell you a bit more about later in the talk. And we have our own science policy interface called CREW, the Centre of Expertise for Waters. There are other science policy groups. There's one on soils called Climate Exchange, and there's another one on animal disease called EPIC. But our one on CREW, it takes shorter term questions for research from the policymakers and the regulators and turns them into science, co-constructs them into science questions, and then we undertake short research projects to give short-term answers to policy needs. So a little bit of a walk through some key aspects of Scotland's landscapes that shape the research and the knowledge we've got. So over on the east, this is the brown and the green zone of the east of Scotland. You see a very arable landscape. So lots of barley makes our beer and our whiskey and our cattle feed. In the wetter areas, particularly the southwest of Scotland, we have a lot of grassland that's been intensified for dairy and beef production. Sheep are widespread throughout Scotland on the marginal land especially. But we have a large area of mountain and moorland. And these three land areas are often in a mosaic in the landscape, so we're often managing environments with quite diversity in the catchments. We might have mountainous headwaters and very intensive lowlands, and then putting all that together at a catchment scale. So I'm going to try a little bit of getting to know the audience. So I'd like to see if you can access this live.vox vote on your phone or computer, and we're going to have a few questions. So this can be done by in the audience or online. So we'll see in a moment how many people can pick this up. So I'm going to swap over. The first question is a sort of dummy question that just gets us all started. So not really serious. So in a moment, if you put that PIN number 209813, you'll see the question come up, and you have about 45 seconds to answer, if that's all right. So I'm going to start it up, and we'll see how that goes. So this is just the test to see that things work. So you should, hopefully you see a question now that you can answer. Does that work? Ah, sorry, it's at the bottom. live.vox.com. Sorry, I'll stop it. We've got one person. So 209813. Don't worry, the questions get more interesting. It should work on any phone or... I'll just give you another 30 seconds to get it. Does it work okay? The question, I've stopped the question, so if you want to, I can start the question up again.
I don't see a question.
Yeah? So that should have restarted the question for you. This one's just the trial, remember. So another 10 seconds, and we'll look at the answer to this, and then we'll see the proper questions. Okay, looking good. Oh, sorry, I have to put the next question on. Okay, so this is more serious. So now getting a feel for the audience in the room and online. What sector do you work in? You have 45 seconds to answer. So here you can select more than one answer if you want to. So with these questions, I wanted to get a feel for what kind of balance we are of audience with you know, our experiences around environmental protection and our background. So that's great. We are dominantly academics. It's great that some people are engaging in consultancy or farm advisory work, and we've got some people here from policy and regulation. Great. Moving on. The next question, so aspects of your daily work, you can again answer more than one question, so I'll just start that. Sorry, you can give more than one answer, I mean. Okay, last few seconds. Okay, so we're good environmental generalists. There's a strong background of agronomy to the audience, and a reasonable split of people involved in water quality, soil sciences, ecology, biodiversity, and drinking water protection. Not so much circular economy and not so much fisheries. Okay? Next question. Do you have any direct experience with the following environmental actions? You can select more than one answer again, apart from the none of the above, that's exclusive. Last few seconds. Even spread. Okay, so top answer, farm nutrient planning, soil health, buffer zones, some people with none of the above, and 20% of people involved in riparian and river restoration. Okay. Then in terms of the main drivers of need for agricultural mitigation actions in Uruguay, what do you think? Again, you can select more than one answer. Okay, so the top answers. Protecting rivers and lakes generally, protecting drinking water sources, and achieving water quality standards. So much less emphasis on reducing flooding as the lowest, and then protecting coast or river fisheries, countering biodiversity loss, and protecting bathing waters and recreation are sort of middle level drivers. So about environmental protection of waterways and diffuse pollution and drinking water sources. Okay, and the last question in this block, so very specifically about riparian and field edge buffer zone application to Uruguay. So this is a one single answer only. Okay, so by far the dominant answer is that riparian and field edge buffer zones are applied in Uruguay in a limited way and with small extent. But some people thinking they're not generally applied. Okay, so obviously that's not very scientific, but it gives us some idea of the motivations of the need for looking at riparian and buffer zone management in this country and the level of the practice at the moment. So that's great. So I've got 3 questions about evidence later, so hold on to the link for now, but I'm just going back to the talk. Okay, so what issues are we facing in UK and Europe, and probably similar here? So the big issues I think are going to be the same. Rivers are regulated in flow morphology and they're isolated from the surrounding land. Agriculture and developed land is losing habitat diversity. Wetlands and woodlands are disappearing. Water quality is in some ways improving, but it's being challenged by new pollution. And climate change is interacting with everything, really. So these are all very familiar, and these are tackled across the world, and they're embedded in, for example, the UN Sustainable Development Goals, particularly 13, 14 and 15, which are about the natural environment, but also closely with some of the community ones, like the access to safe drinking water. So when we're doing catchment management, it's very much about uniting perspectives, and buffers are a perfect example of this. So you may on one hand have an ecological perspective where it's all about aspects of environmental quality, but it's very important that that's undertaken in balance with the way that we use the land and our natural resource management perspective. So buffer zones are a perfect example of that, in that we're trying to apply environmental measures within a busy production landscape and a place where people live and work. So just to think a little bit more about the challenges for catchment management, there's very much a restriction of space and natural form with watercourses. Or this is certainly the thing in the UK and Europe. So on the left there, actually 2 examples from Scotland. There's near Speyside in central Scotland, there's some flood embankments alongside a stream to protect the adjacent land. So that's a restriction of access to the connection of the stream to the floodplain. A very typical picture in the centre of a straightened and ditched farm watercourse with very sharp corners So the stream taking 90-degree bends through the landscape around the field structure and being over-deepened and disconnected from the land surface. And then this type of thing is recognised globally. A very extreme example on the right of production of vineyards and orchards in America that's totally led to the change in the form of this large river. So the loss of habitat is a big challenge too. This is again quite an extreme example of a photo from the Netherlands. These are photos from Scotland, and what we're looking to do is to, in the land adjacent to the waterway, it has a special role in the environment, and we're looking to increase the natural habitat of that area, and that's a key zone to do management for different things, including habitat. So it's a challenge that our streams and rivers have been modified to act as drainage pathways. When we look back at old maps, this is from Scotland again, this is some of the early maps from 1830s. Of course, these are a little artistic in how the landscape is represented, but they give an idea that the waterway was a very wet bottom of the valley with a braided natural river section. More advanced mapping came along quite soon after that, and the change that you see is one of quite intensive drainage, the period of agricultural intensification. There were straightening, ditching, use of dynamite to lower streams and remove rock, and the so-called improvement of the land. In the modern time, many of these drainage networks have become underground pipes, and that further removes the processing of the river and the way that it deals with pollution. So there's lots of sources of pollution. They can be field runoff, they can be animals, they can be agrochemicals, they can be sediments. In many ways we are starting to address those, but as we do, new pollution comes along. So we have antimicrobial resistance genes, pharmaceuticals, new pesticides, daughter products and breakdown of pesticides, and then microplastics. All the time the climate is giving us something new each year. Every year there seems to be a record. It's the hottest summer, it's the wettest autumn, etc. Every year in the UK it seems there's a new climate record, and that continued in recent years with a very hot and dry last summer and spring, and a very wet, unusually wet January this year. So we've looked at, in other parts of our course here, at some of the fundamental concepts around source, mobilisation, delivery and impacts, and they still remain important, but there are many things around those. When we look at in-field mitigation, see the arrow? No. When we look at in-field mitigation, we see it acting on mobilisation and delivery pathways, but also there's water body restoration and rehabilitation to try and manage impacts in the water bodies. So there, at that space, is this new sort of nature-based solutions goals where you're trying to use nature-based processes in order to manage pollution and improve the receptor condition. All the time acting on sources, mobilisation, well, delivery and impacts is climate and land management change, especially for our science area, climate and hydrological extremes. And then there's the whole human system to add, and we try and understand the human system towards better management with our monitoring, water quality and increasing use of sensors and data and decision making, and we have the management actions driven by policy and regulation and maybe industry, helped by science and technical innovation, but needing behaviour change. So what do we need to do? And then the sub-questions of that are, does it work? how does it function, and what are the intervention scales for different outcomes. So in the UK, Ireland, Europe, recently there's a thinking of changing from narrow grass margins to a more diverse set of management actions that you can do in the riparian space. We recognise that current riparian margins are poorly performing, so that's particularly the case for narrow, maybe 2-3 metre wide grass buffer strips. We find areas where there's a high clay percentage in the soil, that the sediment load and the particulate phosphorus load goes through the buffer strip very easily, for example. We need more innovative use of design structures from below the ground to the tree canopy to increase benefits. I'll show you more of that. The methods for improving locating buffers are increasingly feasible, and there's aligned initiatives around different goals in society for river woodland, river restoration, and flood and drought management. So we've looked at elements of designed riparian structure. So these are things in a more natural landscape that are there anyway, and in an agriculturally managed landscape we've taken them out of the situation. We've simplified. We have homogeneous cropping, we've removed some of the natural parts of the field, and we've taken some of the structural elements of the landscape away. So we want to put some of those back. So with trees by the watercourse we can reduce spray drift for pesticides and herbicides. We can try and trap runoff and sediments from surface runoff. We can do that 2A, the arrow shows we're doing that through grass filter strips and rough vegetation and shrubs, or 2B, it may be that you need to change the ground situation, resculpture the ground and add a sediment trap. We can look towards lessening soil compaction and increasing infiltration so that some of that runoff is processed in the soil. We can try and encourage nutrient uptake into vegetation, and that may lead to options to remove nutrients from the margin in terms of biomass removal. Soil organic matter is good for biogeochemical processing, so we want to try and improve that situation. For us in the UK and Europe, there are many areas of wetter ground that have been brought into production with the use of artificial drainage. It was a widespread practice, and it was funded for many years after the 1940s and 50s up until about the 1980s. So there were many field drains. So for us, that's when you look at a buffer strip and you stand at the field edge, you could have a buffer as wide as you like, but if there's a dominant pathway going under your feet, then you need to realise that. It's very important to make the connection back with the channel and the floodplain. It's very difficult in some of these over-deepened agricultural channels to do that, though. It involves raising the water level for such a height that it really is a problem. We'd like to introduce leaf litter and woody debris to give some natural processes in the stream. We'd like to stabilise bank erosion. Studies of sediment yields and catchments still show that bank erosion is a dominant load of sediment, and these sediments can be quite enriched with nutrients still. It's not just about the field surface runoff. And then with climate resilience, we're looking to guard against high temperatures in water that increase the algae. So we're looking to shade with trees. So just to talk through a few of those. So tree planting is a widespread goal. The benefits are best with native broadleaf trees, but it needs a design, establishment time and management. So that often has to be funded. There may be fencing or individual tree protection involved at cost. Often margins are sown with a wildflower seed mix. So that's about improving the biodiversity with wildflowers. But at the same time, the vegetation biodiversity cannot be as great as it once was because the land has drained. If we had a mixture of soil conditions with wet and dry areas, we would have a better diversity of vegetation. So we look as well at the need for raised ground features. So these can be storage of runoff from the field, or they can be storage of overbank flow from high flow of flooding. And it's about temporary storage of water in the landscape without ruining a crop, but providing enough temporary storage to drop sediment out, and they're very temporary sediment retention areas. So they need a bit of design, and the schematic here shows that you can bring some scientific principles to elements of the design with the height of the bund, the pipe that tunes the water outflow, and the position of the pipe in terms of the water input and the soil conditions. So some of the measures for raised ground features can be quite simple. It can be adding some sculpted ground to an existing grass buffer strip. Here a potato ridging device is pulled by the tractor through a 3 or 4, 5 metre wide margin, and that creates these ridge and furrow forms that are perpendicular to the flow path of the field slope, and they're about slowing the flow and depositing the sediment. And in the trials that we've had, we've stabilised that ridge and furrow structure with some wildflower seed mix. Thinking about buffers as being not only freely draining infiltration zones like grass filter strips, but thinking of them as being wet areas of the landscape as well is useful, and that's in terms of treating things like subsurface pathways of nitrate through denitrification. That can be through the provision or enhancement of things like wet areas and wetland zones in the landscape, or protecting existing wetlands. But it can also be, as in this example from the United States, where you're bringing subsurface drainage to the surface in some way and irrigating water onto a wet grass plot. So when we go to I'll put this up as well. When we go to a landscape, we might see farming right the way up to the edge, but quite often we see areas of the land that are not suitable for the production in the field. We might see, as in this photo, areas that are naturally wet being just left as rough vegetation, some trees, maybe an old wetland in good or bad condition, or a wet field corner with natural vegetation. So these are areas that are the opportunity to work with a farmer to engage and use them for mitigation. More or less they are wet because they are the lowest point in the field just before the watercourse, and the water that comes through the field flows through these zones. So they're next to the delivery points on the stream network. So in many cases they are bigger than the minimum regulatory buffer requirement, but they can be enhanced in some ways, or they can be just left and protected by different things like fencing and cattle exclusion, and they become the areas that are really good to have a conversation with the farmer about where to work on a field. When we're looking to have these conversations, we're looking to say that there's more you can do in a grass buffer strip than perhaps you thought before. So in terms of bringing measures together from around the world, one thing we've done is to develop a set of 16 measures and to look at those for options that a farmer might take. Some are very simple, some are very unfamiliar, and some, like a sediment filter fence, are a very specialised circumstance only. But we can draw together science and studies from around the world and try and bring these towards better guidance. So I'm just going to walk through these and explain them. So grass buffer strips, wildflower buffers and wooded buffers are quite easy to explain, and you'll be familiar. Magic margins are the ridge and furrow system that I described earlier. Raised buffers for either field runoff or overbank flow, and sediment traps are fairly easy to understand too. They're not very commonly carried out, but they've been quite extensively studied, and their effectiveness is well known in some circumstances in the scientific literature. Enhancement of wetlands in the landscape is quite well known. Bringing wetlands at the end of tile drains and cutting the tile drain back from direct discharge into the watercourse is not well known. It seems to be a practice that happens in New Zealand, but not many other places around the world. Integrated buffers were a package system where we brought together field drains being discharged into a linear wetland with wooded buffer zones. Denitrifying bioreactors and sediment filter fences are very specialised, as is controlled drainage and saturated tile drains. There are options to do things within the ditch space as well, if the rules allow. So broadly, these measures are the basic margin space, measures you might bring in if you're concerned about surface runoff and sediment erosion, measures you might bring in if you recognise subsurface pathways are important, and some options to work in the channel. So you can simplify a sort of menu of 16 measures like that with some general principles. You could say at the top we might want vegetated grass buffer strips, or we might want to add some wooded elements or some vegetation elements, some wildflower mixes. And then the bottom two are increasingly more about changing the ground for some of this sediment retention. So simple bunds and sediment traps in the raised field margin, and then a more fully engineered system at the bottom might deal with things like field drains additionally. So the arrows on the right show that as you go from the top to the bottom, they're more about what you might do when the pressures are more strong. They definitely, from the top to the bottom, take more cost and effort, and at the moment their acceptance is poor at the bottom and much better at the top. So when we do buffer strips and field edge and riparian actions, they need to be part of what I would call a treatment chain. So if you did your buffer strip alone and your field practices were really bad, then the buffer strip would be overwhelmed by the erosion, and you would have too much erosion from the field, and the buffer strip would be useless near. If you had a very poor water course, you might say that it's less important to protect that. So everything goes in a chain. So it starts with the in-field mitigation, erosion controls, good soil condition, limiting compaction, etc., nutrient budgeting. And then elements of farm infrastructure. So they could be the farmyard management, they could be the runoff management of the tracks and gateways, and it could be good siting of animal feeders. In terms of water body condition, good geomorphology, good shading, carbon supply, ecological connectivity, floodplain connectivity are aspects of resilience. So the whole thing works together like a chain, and it tends to be if you break one link of the chain, then the whole system is weaker. So in thinking specifically to buffer zones now, what's the evidence? If we look at the evidence from across that's been brought together globally in studies like this one by Hadaway in 2018, there are stronger areas of evidence, for example nitrogen and phosphorus, and in this case they found terrestrial habitat, and there are weaker areas of evidence, for example the aquatic habitat and biomass. Some 20 years ago, the conversation was about how wide your buffer zone should be. I think now it's a little less about how wide it should be and what you do in that width. But this diagram shows when you put studies together 20 years ago, there was a broad range of widths that were shown to be effective in different study situations. If you looked at things like bank stabilisation, it made sense that you could achieve stable banks through rooting of vegetation in more narrow buffers. If you looked at things like terrestrial habitat, it was edge effects and ecological effects that meant they were very wide margins where you got the best benefits for terrestrial ecology. So these widths of 10 to 100, greater than 100 metres, are really challenging in busy agricultural landscapes. So it's all about what you can do effectively in a smaller space. It's probably fair for the farmer to take margins of perhaps 5 to 10 metres than it is to take margins of 100 metres, unless you had lots of government money to spend, which we don't. So if you look at the data and you try and answer these questions about what's the effective buffer width for reducing a load of pollution, then you come up with these very messy data sets. So here, in terms of the axis on the left is the mass load reduction, so a typical study measurement of the mass inflow against the mass outflow, so the concentration times the water volume, and trying to understand the retention of a nutrient or the different nutrients within the buffer space. So many of these studies are plot studies, but there's lots of them brought together, and they're very complicated to understand even when you try and unpick the different vegetation types. If you try and draw general principles, this can help, and things like the soil texture become quite master variables. So I mentioned earlier that clay-rich soils with a fine clay particle size being mobilised, they can travel through a buffer zone more readily than a sand texture can. So the sand texture, the drop of velocity in the buffer zone with the flow reduction deposits the sand, but the clay, the fine particles, are carried through. So you can draw some of these principles around width versus effectiveness, but you start to notice these peculiar concepts of a negative effectiveness. Partly their study attributes of not constraining some of the input flows, and in part they might be, for phosphorus, there might be re-release of stored phosphorus within the system. There was good news, however, when you look across global testing in terms of plots that compared a control against the presence of a buffer zone. The blue bars show an overall positive significance of the benefits of having a buffer for the different nutrients. I mean, you can see, of course, that some studies showed there was a negative result, and some were concluding that it was a result not significant. But overall, things like sediment, very strong evidence that sediment yield is reduced by having a buffer zone. The picture is a bit more complicated with things like dissolved phosphorus. The message to take from all of this evidence is really that the measures are quite place specific. So there are needs for further evidence that's quite difficult to get. These are around some of the community benefits. They might be improving the visual amenity, or might be public access to the side of the rivers. The improvements to farm infrastructure, for example, the farmer using buffer strips to cross the stream, or increase of pollinators and benefits for the farming, and also stream shading and temperature regulation. These are things that need more evidence. So in a little bit more of the voting, I wonder if we could have a look at where you feel the evidence gaps are in Uruguay or South America in general, and we're going to look at 3 branches of gaps quickly. So water quality outcomes, habitat outcomes, and wider ecosystem services. So I'm just going to come out and go back to it's the same system again, it's just the next 3 questions. So I'll go to the next question before I start it and show you the format. So here, this is in terms of water quality outcomes. So there's a list of things that field edge mitigation might be able to do. And I want you to say whether you feel the evidence is weak or whether you think we need to do more to develop it to stop it being a barrier to practice. So it's a whole combination of things. Where do you think we need to put more effort? Is it in trapping sediment, or are you happy that that's, we know enough about that to carry on? Is it, that there's a low evidence on pesticides? Maybe that's not needed, so maybe that's not a priority. So it's a combination of where's the evidence and what's the priority. So have a go at these 3 questions. Okay, last few seconds. Okay, so as an audience group, we feel that there ought to be more done, particularly with pesticide capture and breakdown, nitrogen capture and nitrogen transformations, and phosphorus capture and retention. Less interest, but still some, on microbial contaminant retention. Of course, trapping sediment is a fundamental sort of property behind many things, so it's always good to know a bit more about that. Okay, yeah. The next question may be some things that you don't think about quite so much. So we're looking at habitat outcomes and things around habitat. So hydromorphology obviously is connected to habitat, even though it's a biophysical thing. So, have a go at that one. The last 10 seconds. Okay, fairly even. The winner is terrestrial habitat, so that's important, but also aquatic habitat. And then next priority would be, or close priority, ecosystem carbon cycling and hydromorphology. They're relatively even. And this is the last one. So this is more broader ecosystem services. Feel free to say we shouldn't bother with any of these if that's your preference. Okay, what do we have? Okay. Actually, I'm thinking that might be quite similar to UK opinions. So, very much current in thinking is reducing the effects of drought and low flow. So that's a key thing to work more on from your opinions of here. Benefiting agronomic processes, the buffer strip working with the farming. That's good. Reducing flooding. Okay, interesting. And some community aspects being viewed as important. Great. So I've got those stored, and we can take those and look at those answers later. And I'm relieved with the IT working as well. So thank you. So where should we work? How should we work in a catchment basis? This is a sort of UK and European look. It's very much on the left that fixed width management has been the thing that's easy to action. It's easy to legislate for a mandatory 2 metre width buffer strip, for example. And when we do GIS investigation, it's very easy to now put a measured mask around the side of your channel network and understand the fixed width buffer zones. So if we go up a level of complexity, we can say that we might want to introduce variable width, and we can do that in different ways. So we can have, as in 2, we can have variable width by attributes, and the attributes might be the structure of existing landscape features like wetlands and pockets of semi-natural vegetation, or protected habitats. Or at 3, they might be something that's around the context of runoff or required protection. So for example, drinking water treatment zones with special actions, or really polluting fields that have specific actions. So the basis for a lot of this has been some of the GIS tools, particularly around the critical source area thinking. So this brings together 2 aspects. So the first aspect is the source areas, and we can look at source areas in terms of risk like erosion, modifications of cropping or soil compaction, and the soil testing. So we might say that if there's been poor nutrient management, the soil has a high phosphorus test, or it has too much nitrogen or too much manure added, and it becomes a high source risk. And then there's the connectivity aspect. So in critical source areas, they often use hydrological response zones, which are more or less areas of wet soil that generate runoff readily when it rains. So as you're walking around the landscape, there'll be the kind of things when you've got your boots on that your feet are getting muddy when you walk around a field. So they can be only occurring in the winter. They can be occurring all year round. They come prevalent when it rains. So you end up with the connection of those makes the critical areas to intervene. So this is a little schematic to show an illustration of how that works with a buffer zone. So on the top left of the drawings is the situation of diffuse flow. So that's say it's a 10 by 10 or say it's a 100 by 100 metre field, and it's a 10 metre buffer zone. If it's diffuse flow, then the flow is coming through that buffer zone, and most of the buffer is acting to control the flow, and that gives you a certain source area to buffer ratio. So you've got 10% of the field being the mitigation zone, and you've got a source area to a buffer area of a factor of 8 in that case. It's very rare that that is the situation. It's often that there's some kind of mixture of diffuse and converging flow. So by converging, I mean that the topography works so that flow comes around, gathers in a small channel, either natural topography or perhaps the wheels of the tractor have added to that, or the step of ploughing, and it modifies the flow and it brings the flow to a converging point where it gathers energy and it breaks into the buffer zone at a small segment of buffer. So in that case, the dark green areas in the middle, you have smaller areas of the buffer being effective. So then you have a much greater source area to effective buffer ratio. And what we can do to change that situation is to modify the buffer to be larger at the points of delivery. And that way you make the buffer work more hard for yourself. You may be able to bring the area of the buffered field lower. So how does that work in reality? So these are some fields to illustrate that. The dark lines are the flow pathways. So these are fields in Ireland, and they have water courses, there's ditches and natural streams around most margins of the field. So if you wanted to do linear buffers, you might do this, say a 4-metre buffer to all water courses. But if you took notice of the flow lines and the points of delivery, you might instead do this. And you could say that it would be better to plan in those fields for 2-metre buffers everywhere, plus targeted buffers that are wider for the points of delivery. So one of the things that planning that we're used to having now is GIS data. We talked earlier this morning about soil data and risk mapping, and there seem to be good opportunities for using your soil data within Uruguay, and these are some of the type of products that we use our soil data in Scotland to derive secondary risk data sets around things like soil compaction, leaching and runoff, and soil erosion. What we're increasingly trying to do is to build benefits of mitigation measures in a network of farms to bring the benefits to a catchment scale. So this is especially important when the benefits are realised down the system. Examples of those might be flooding of a town or a village that's by the river lower in the system, or it might be that the drinking water abstraction point is lower in the catchment, but the important areas to undertake the management are in the upper parts of the catchment where it's perhaps steeper or more erosive practices. So we end up with different zones having different things. Often in the steeper headwaters, it's about stopping the energy at the point of it starting in the system. So it's about stopping fast runoff and erosion and stopping the nutrients and the sediment getting in the channel in the first place. Often lower in the system, it's about the ecological integrity of the system, and that might be channel floodplain linkage, it might be wetland and habitat, and it might be specific things to treat water, but it's more likely that you're doing the ecological measures down there. So you can have different strategies up in the headwaters, but it's all about connecting parts of management and understanding what that effect is going to be when you look at scale. So I'm going to look a bit now about regulation policy in the EU and UK and Ireland. So this is the first time I've asked AI to generate a little word cloud for me, and it gave me this after a lot of trying. It gave me this as a word cloud of legislation around water in the EU. So it's a very crowded space, there's lots going on, and actually most of these policies don't talk very well to each other. The fundamental underpinning of the policies for water are an EU-wide thing called the Water Framework Directive. So this says that your water bodies, unless they're heavily modified and you can take them out of regulation, it says that your water bodies should be in good ecological status, and it set times when it expected that to happen. Of course, most of those times have passed and it hasn't quite happened yet, but it's the process of trying. So there's been cycles of action since 2005. Very early on, buffer zones were in nearly every plan for every river basin district. They said, let's have buffer zones everywhere. Nowadays, it's quite diverse. There are things like resilient communities, sustainable water usage, private water supplies and circular economy in the plans. But essentially, there's a plan that runs for about 5 years, and within that you review the progress of the last plan, what's worked, what hasn't. You consult on the measures in a plan. You know, it's fair to have measures that farmers should do, that foresters should do in the plan. You publish the plan and develop strategies, and the regulator runs the plan with the scientists for 5 years. And then that's all tied in with our monitoring network. So this is the regulatory monitoring of the United Kingdom, and then we get our classification of whether our rivers have attained this good ecological status or not. So all of the colours in that picture that are red, orange or yellow still require improvement. Green or blue are the things that are meeting the standards so far. So plenty to do. In terms of policy developments, these are some of the latest things being talked about. It's underpinned by ecosystem services. So the wheel of ecosystem services here shows things that you'll be, I'm sure, familiar with around provisioning and regulating other environmental services. So that brings the natural capital approaches and the management of natural capital of soils and waters and habitats quite strongly into policy and planning. And that links, of course, with nature-based solutions and climate resilience these days. I've mentioned beyond compliance because compliance is the baseline for good practice everywhere, but compliance is often very basic. Compliance is about perhaps not having really bad erosion or animal practices, but it's very, very basic, and it's to get everyone on a basic level. And then the beyond compliance is where you're looking to do the nature-based solutions, the climate resilience, the enhancing ecosystem services, and that takes advisor effort and funding. But what we need to build this is demonstrators of this at catchment scale. So what about catchment scales? So we have this regulatory baseline of good practice, so this compliance level. And then for the beyond compliance, we're looking to catchment partnerships. In the UK, these are often driven by the river trusts who have a fisheries protection role. So they might involve regulators, water companies, scientists, and fisheries and rivers trusts coming together, maybe national parks and protected area representatives coming together and making plans that are beyond the Water Framework Directive plans. So part of that is access to national funding. For example, in Scotland there's a nature restoration fund from our Scottish nature regulator that allows you to work in waterways with some of the river restoration. And there's a strategic need to join up across policies and agencies. It's recognised that some of these river restoration projects are very slow. They take a lot of money in the planning stages and the doing stages. And what they want to do is bring together example areas where the heads of the different agencies and policy divisions are looking to do that more smartly and more cost effectively by working together and understanding what the barriers are to working more cost effectively. And this is under a thing we call public sector reform, trying to stop so much money being spent in the country. As scientists, when we work in areas, we often find that we're coming up against barriers with some regulations. One for us is working in ditches. We would say that a degraded ditch in a headwater of a catchment like this is a great place for a mitigation space. You can do something in the ditch that means you don't have to take some of the field. It probably works best with something in the field, but it makes sense to do some actions in the ditch. However, the regulator is not very clear on letting us do that. In Scotland, it's a bit unclear as to how they say a ditch is mapped, and it's also goes from person to person in the regulator as whether they think they'll be very strict in letting you do nothing, or whether they'll let you try some actions and let them be a bit more, feedback and understand it. In England, it's just got lots and lots of planning permission required. But again, these sort of measures that we can do in the ditch space would be great if we can be a bit more clear on the regulations. So getting landowners on board is incredibly important. There are some farm advisory services that can make guidance available through web pages, and hopefully they have uptake with farmers. These are farmer-designed communications, so they have some good practice stuff, and the communications are backed up by some of the farm visits. So I've got a few examples here, and I've got some links to wider examples in some pages at the end. So farm advisory services are very important. I'm going to give an example from Ireland about the Irish Catchments Programme that I'm becoming familiar with for several reasons. It's based in the Water Framework Directive, and it's part of the National River Basin Management Planning. So under that, they do some modelling first, and they come up with areas where the pressures are most intense, and they're called the PIP maps, the pressure maps. And that links to areas that have been selected for research. So they have agricultural catchments, and they have a programme of measurements and understanding the delivery of diffuse pollution within example catchments in the country. So some of you have worked with Ireland, and some of my colleagues in Chigask and other universities on some of these programmes maybe. So turning to the advisor capacity, so that's in two branches. So the local area water protection officers under Law Pro, they undertake visits of catchments, and they understand where the priorities are to work. So they then refer to another set of advisors to go and do farm visits. So the farm visits are carried out by a group called ASAP, the Agricultural Sustainability Support Scheme, and they are now 60 farm advisors nationally in the Republic of Ireland that do farm visits. So the idea is that they're familiar with an area, they look after an area, they work with the farmers on longer term, they're trusted, they give advice, they work with Law Pro so that the advice comes together at catchment scale. And how it works is they've aligned this to some funding from Europe that is under a programme called the EU Agricultural Water Innovation Platform, and that has got now a pot of funding of 50 million euros. So that's competitive, and they make applications. The farm advisors help the farmers apply for that, and it's a relatively new system over the last few years that allows much more beyond compliance measures. The data behind that is yet to be brought into a synthesis, so it will become available soon to analyse the level of uptake, whether the uptake is just really basic measures or whether the uptake includes some things that are more novel, like sediment traps or river restoration, or whether it's all about grass filter strips and fencing, for example. Well, actually that's compliance, so it's a little more than that. There'll be a lot of measures around the farmyard, I think, in that as well, tidying up a farmyard and slurry storage. And it would be good to bring the data from that towards an understanding of how the measures are performing as the farms join up in the scheme, do more measures, and how that performs at a catchment scale. So this is current stuff in progress. So as scientists, we're often working in a project where we're going onto the land and doing work, working with the farmer. And some colleagues of mine are very good at generating what we've called farm runoff management plans. And we think of this as fixing things together with the farmer. So it's grounded in the topographic data that makes the flow paths. And then through experience really of the scientists and the landowners the conversations, the walkovers, the mapping. We bring together something called a farm runoff management plan and have some conversations about what measures could be funded. So an example is, at the moment we're working with Northern Ireland Water to protect water supplies and bring some of these measures in a funded programme for farmers that's part of an EU funded programme north and south of the border in Ireland. So the idea is then that this is my colleague Paul Quinn standing in a sediment-laden ditch, that you're out, you've got these plans, you look at them together with a farmer, you talk over which is the most suitable. The farmer maybe thinks from a business point of view, what is going to help my business? The environmentalists think what's going to help the environment, and you reach some mutual decisions on what you can do. You maybe then do some modelling or some scenario work to kind of understand the benefits, and then you end up with a plan, and the plan is hopefully brought to a schedule of works. The professional designers come on site with their laser levels and their monitoring equipment, and they turn that into a plan that's taken to the tendering process. And then the contractors come along, and you end up maybe with things built like this sediment trap. And then some more science on the end of that can understand, does it work? How should I do it somewhere else? Can I do it better when I do it next time? So this is sort of action science. We really need to demonstrate these benefits more as well. So tree planting and grass margins are acceptable to farmers, but this sort of ecosystem engineering has negative perceptions because people aren't used to it. And they worry about how it's going to be resourced and paid for, and they worry about how it's going to be managed. Especially with farmers, their parents, their grandparents have spent a century of improving the land by removing water as quick as possible when it rains. So there's a negative perception of wet ground on farms. They don't understand, oh, for years you told me to do this, now you're telling me to do this. It's very difficult for farmers to think of a river network and drains as anything other than fast removal of water when it rains. So we're going to look at financing. How can we finance these things in the beyond compliance? So there are agri-environment schemes for farmers. These have funding for applications for additional measures. There are some other things as well around trading of things like carbon. So in the UK and Europe we have carbon trading schemes called carbon credit schemes. They mainly are concerned with the management of soil carbon or woodland carbon. So they have come into the water sciences and management by working on things like dissolved organic matter in watercourses, or working with woodland for water, or woodland for multiple benefits, including water benefits. We need to encourage a mix of public and private funding. There's not enough money in the public money to do some of this beyond compliance. The needs for that are market structures, such as carbon credits, of economic and ecosystem valuation of benefits, and metrics for outcomes. So these are all really quite difficult things to put in place. And we also need to remember we're funding not only the measure being built in the first place, but the essential maintenance of it through time. Just to show you a couple of things, these are the 3D buffer concepts that we've worked on with the government in England and Wales, and we were very pleased to see recently, always nice for scientists to think what they've done is worthwhile, that the 3D buffer concept has formally gone into funded measures in England and Wales now. So the farmers can take some of these options, woodland, sculpted ground, sediment traps, bank protection, and they can do a range of things, but they're given some funding for the capital, and they're given, I think it's 20 years of funding at £1,200 per hectare per year for 20 years. So that's in England and Wales. A little bit slower in my home country of Scotland, but the magic margins this ridge and furrow addition to a grass filter strip is in a consultation phase at present for funding in the Scottish agri-environment schemes against grassland and arable. So that's good too. Natural capital is a big conversation at the moment. It's perhaps not. It's in early days, let's say. So it's good to bring alignment across policy areas, and we aim to have it in river basin management planning. So this was a nice report recently. There's a link here done through CREW about natural capital and river basin management planning in Scotland. So on the right are some of the recommendations. So to bring this in, it's good to strategically align policy and funding decisions. It's good to adopt a whole catchment approach. We need to make natural capital work. We need to strengthen evidence and modelling. It really relies on an integrated monitoring framework with the right endpoints in order to understand whether the outcomes have been derived, because the outcomes link to the funding. In unlocking private investment, you need to prove that the outcome has been delivered, and you also need to support the practical delivery. So I'm going to finish with an area of a case study. So this is not exactly buffer strips, but it's aligned and all the problems are the same. So restoring river woodland as part of river restoration has been a challenge in Scotland, and it needs various areas of science, delivery and finance to come together. So I'm just going to use that as a case study to finish. So this is the Riverwoods Partnership, of which I'm involved with the lead of the science group. So the case for this is that Scotland has 125,000 kilometres or more of rivers, but when we undertake mapping of the riparian vegetation, only 13% of that contains diverse vegetation, including woodland. A lot of it is against farmland, and it has perhaps just some weeds, we would call, so some native plants that love nutrient-rich soil, and no woodland. So we say that urgent catchment scale action is needed. So the vision of Riverwoods is a network of river woodland and healthy, resilient river systems throughout Scotland that deliver a range of environmental, socio-economic and financial benefits. So the aims of the initiative are to connect ongoing and potential river woodland projects throughout Scotland, and to facilitate the collaboration, the responsibility and knowledge sharing around best practice. So the Riverwoods is an initiative run by Scottish Wildlife Trust with many partners. It has a big growing network membership, and it has an oversight group, and then these action area groups. So I'm involved in the science group, but it also has a group looking at advocacy and policy, delivery and finance. Recently it won a very large funding project from the national, we have, it's gambling actually, but we have a national lottery, people that buy a lottery ticket, and that gives away money to charitable and initiatives. So the Riverwoods gained, I think, £3 or £4 million from the lottery several years ago. So that's funded what we've termed a blueprint project to set the blueprint for more restoration of rivers by woodland in the future. So the blueprint project has these elements. It has demonstration areas. It has a development grant for projects for demonstration areas, community engagement and training, a digital centre where it stores best guidance, some GIS resources that help people plan. It has a governance structure and the partners, it has a comms group, and it has an advocacy group. So the Digital Centre of Excellence is a hub of the tools that they've brought together and resources for practitioners, land managers and community groups looking to carry out the projects. So it's got case studies of success stories to try and promote river woodland, It's got resources around understanding baselining, water quality, the mapping of the existing river, woodland and vegetation. It's got resources around guidance and project development. It's got the development grant scheme, which over last year had 28 applicants and 11 funded projects. Relatively small funding, but enough to get community groups involved in woodland projects. So what are the type of things that we're doing within this action in order to try and bring more of this river restoration? So in terms of advocacy, there's a need to influence the developing policy and raise the profile and recruit our supporters and influencers. So that's amongst NGOs and agency and regulation and policy. So the delivery group is working on barriers and how to overcome them and how to get more projects and support them. The finance group is looking into ecosystem services funding, new ways of doing public-private funding, and how to particularly go beyond carbon as a funding market. We might want to see things like clean water or pollution trade or phosphorus trading as underpinning payment regimes for river restoration. And then in the science area, we're trying to understand evidence, identify gaps and interpret the evidence, develop best advice for monitoring, promote best practice. And it's particularly important that if guidance is general, we should be able to give guidance for specific rivers, and that's in terms of these things I mentioned about the scale of implementing measures against the scale and the position in the catchment of required outcomes, and also taking into account the things like the hydromorphic type of the river or the scale of the river. So going beyond general guidance. I wanted to mention specifically the role of monitoring. So monitoring is really important, and the monitoring underpins some of scientific evidence, but as I said, it also underpins leveraging funding and understanding and promoting impact. So this schematic shows a sort of complex picture of all dimensions of monitoring with relevance to river woodland projects. So we want to monitor better, we want to improve our methods, particularly things that people can be carried out by more than just scientists. We want to bring data together for better understanding. Perhaps we bring data sets together and have some common analysis. We want to unlock evidence towards resolving conflicts, understanding effectiveness and setting targets, and we definitely want to raise impact. So it's a really common question in lots of river projects where people come, the community groups come to the scientists and they ask, how should we monitor? Please tell us how to monitor. That's a very difficult question, because if you do a lot of monitoring, you use a lot of resources and it becomes very specialised very quickly. So we've developed some thinking around bronze, silver, gold levels of monitoring. At the basic level for bronze, we'd like all the projects where they're doing environmental improvement around rivers, this is buffer strips, river woodland, to just document what they've done. So this is the kind of thing that advisors are doing when they visit farms. They've got a computer system that's linked to their initiative. Community groups might want a website made by someone where they can enter data, or they might just want to write it down and talk to someone about it. But understand what you've done. If you said you're going to plant so many trees, have you done it? Have you planted them in the right places? Have they lived or died, for example? So that's the basis of understanding. And then the next level is about what's that project done. So at the silver level, we would say that you can do some basic monitoring. We'd like to put things in hand of community groups, citizen science monitoring, but we recognise that there's help needed from scientists to do that. At the top level, it comes to very much academic-led initiatives and specialised analysis. For example, remote sensing, sensors in the rivers, analysing of samples. That is in the realm of science, and that's costly. So that tends to be done in research areas with an ability to translate the results from areas to other areas. But it's a really key question in how can we monitor. So, the summary. In terms of technical research needs, us as scientists, we need to help provide a greater range of measure designs with evidence from our trials. We need to run research-oriented demonstration sites, and it would be great if those were not just plot, but increasing benefits at catchment scales, multiple interventions leading to something bigger in the environment. We need to give knowledge on functioning and inform guidance. And we need to work on some of these planning tools, the spatial data interpretation. And then in terms of policy and practice, so this is maybe from our policy colleagues working closely with scientists, this is maybe from our interdisciplinary, transdisciplinary science with our socioeconomic colleagues. We need to understand the opportunities and limitations of the measures. We need to work on a system where advisors are out there and trusted by farmers and able to engage on designs, costs and funding, placement and maintenance, backed up by the correct science. We need structures for public-private funding and to go beyond basic compliance. And we need the collection and synthesis of data showing the outcomes of national actions, particularly towards the catchment scale. So I'm just going to finish on my action science for impact. So this is where, we're a dominantly academic audience here. If we're out there working in the environment, we want to be doing action science, perhaps not just desk science. There's technical science, but it's great to be out there doing something. And there we need to be connecting solutions with the actual problems, talking to farmers, bringing science and practice together. Properly defining the questions with the different stakeholders. Very much in science you can hold back and not want to do something until it seems perfect. Forget that. Just have a go, monitor it, review it and revise it is my advice. What you ought to do is think longer term projects. Don't just think, if I go to a catchment, I've got the duration of a PhD study to do something. It's great if you work with the area, understand the situation, know the farmers, and your measure is hopefully going to last longer than 3 years, and you want to understand its problems that it has later with maintenance, for example. And have a resourcing strategy for the present and the future, capital and maintenance. Consolidate successes using demonstration. So I really like working in this space of action science out on the land with landowners. There's a few pages of further guidance and resources. I'd like to acknowledge many people I've worked with, and then to say thanks for listening and any questions. So I think we can easily do questions from the room. Yeah.
Hello, I'm going to break the ice.
Thank you.
I wanted to ask you, what do you think about our climate, that we have a very strong rainy episodes, and we have flashy streams, very flashy streams, with a great variability of flow, and very strong storm events. And how do you think that I don't know how the climate and the rain pattern is in Scotland, but do you think that we need additional measures in Uruguay in such a climate?
Yeah, okay. So not knowing exactly how it works when it rains here, but our situation is that we have intense period of storms and we have also lots of smaller storms that are more common and have lesser challenges. In many circumstances, the very big events that happen, once every few years or once every 10 years, they're very difficult to manage, and we can't really do that much about those. It brings more society questions about land change, which are difficult. It may be that some of the funding in the bottom valley of a big river might say, we'll fund you to convert arable crop to grassland, because when the big flood comes, the arable crop has got it's not there anymore, and the soil that would be lost is perhaps protected under grassland, and the animals can be moved temporarily if you know the storm is coming. So there might be that, but at the same time, farmers don't want to do that because the fertility of the alluvial soil in the floodplain is often the best, and the topography is often good. So we can try and do something like that for the very, very big storms. For the smaller, more regular storms, it's probably appropriate to bring the wider buffer zones to the areas of the delivery from the convergent flow, for example. But in the big storms, they would be severely challenged. So we feel it's more in the UK and Europe the frequent medium-scale runoff events that we're able to manage for, and the big ones are outside of our control for diffuse pollution measures. They're more a land change question. I don't know if that's quite the right answer, but there may be certain things that we can do that agronomy is able to provide seeds and crops that are more resilient to temporary ponding water. It might be, the same with drought as well, to drought. It might be that we can change how those areas work that mean that we can bring mitigation more widely across floodplains and store water temporarily during bigger flood events. But we need some technology changes as well for that. So I feel like we're managing the smaller and medium events that happen more often, but there are very big events that we can't do anything about at the moment, and they're usually, for flooding, for example, they're heavily engineered. They're flood walls rather than natural flood management. But for diffuse pollution, you don't have an ability to put up big flood walls that stop the sediment coming to the channel. It just comes, and it maybe moves through the system quickly to the sea. But the farmer has lost a lot of soil. But they're difficult events to deal with.
Okay, I have one question that's very specific, but I'm surprised that you get to have so many agricultural advisors to get to the farmers and give them advice. So how, because here there are a lot of technical advisors, of course, but they have usually like a conventional education where these topics are not part of their studies. So did you give them specific courses over the years, or how did you get to have a big number of advisors to know about the things and be able to advise farmers in a bigger scale? I think, as you said, you have done in Ireland.
Okay, so Ireland I'm learning about because it's not my home country, but I am involved in some review of the programme this year, so I'm learning more about it. I'll finish with Ireland, but start with England and Scotland. In Scotland, the advisors are more on a commercial basis, and the farmer pays for the advice, and there the soil testing would be done under contracts with the advisor, and the farmer pays. So it's up to the farmer to decide if that's a benefit. But there are enough advisors to make the consultancy work. They're within the Scottish Agricultural College. And then other advisors are more within environmental projects, but they're usually paid for by projects or paid for by the fisheries. In England and Wales, they have they've identified priority catchments where they fund some catchment officers and they act as the coordinators and advisors. But the core of that is, again, consultancies where the farmer pays for the advice. In Ireland, the situation seems very nice. It's using EU money again. So this is the Republic of Ireland. So the advisors are they're half funded by the EU. The money to do the measures is funded by the EU, but the 60 advisors are half within Chigask in the working with scientists, and then half of them are actually through the industry. So the dairy industry, dairy cooperatives, provides about a quarter of the advisors, and the meat industry, the meat producer industry, provides another quarter of the advisors. So it's a joint funding package, and I think it's been developed and expanded over the last 5 years to be the number of 60. That's a very good number for the area, and if they can keep them in the jobs and not have them changing jobs all the time, and keep them for longer term, then they become very familiar with the farmers and a trusted local advisor, which is great. And of course now they have access to the funding package. It means that the farmers take them very seriously because they come with the money. So that looks really good. It's perhaps a very nice system in Ireland that's not as good elsewhere.
Thank you very much for the plenary.
Thank you.
I'm thinking about the scheme or the typology of the buffer zones that you mentioned, and in the case of one of the archetypes that you include that promote the nitrification process, I don't remember exactly the name, but it's the nitrification buffer.
Saturated buffers, yeah.
I want to know if you have some problems with this kind of buffer zone with the aquatic plants. I'm thinking, for example, in Uruguay, maybe completely covered by floating or any kind of aquatic plant. Maybe it's not an inconvenience for the nitrification process, but what happened in Scotland with this kind of buffer zone?
Okay. I would say first that in practice they're far more common in the United States and in Denmark. The wetlands are more common in other parts of Scandinavia, but the wet soil denitrification zones have been tried in Sweden. They didn't like them. In Denmark, a little more accepted, widespread use in the US. So really when we looked at those, it was more as an example that we could try and bring to the UK, but we haven't really done much of that yet. So the idea of denitrification in the soil at the bottom of the hill slope is quite new to us. Hopefully it would be less nitrate then running to the aquatic system, so that the aquatic biology then had the right mixture of aquatic plants and the right sort of aquatic makeup. But there's very little evidence at the moment from the UK. We transfer things from the US. Okay. Great. Thanks very much. Thank you for listening. Yeah.
Thank you, Marc. Thank you, everybody here. This talk was part of a course that Iña is very happy to be organizing, so thank you, everybody.